Let's begin our journey close to home. Look at it, a home to billions of living beings, a small blue world that has sheltered life for billions of years. Earth remains the only planet known to humanity to harbor life, and beyond it, we still cannot be certain whether life exists elsewhere. Among trillions of planets scattered across the vast expanse of the universe, the answer remains unknown. To this day, humanity can only observe the beauty of the cosmos from afar, facing an ocean of mystery that future generations will continue to explore. In the grand scale of the universe, our Earth is incredibly small, surrounded by countless exotic objects that shimmer across the cosmos. Our planet is no more than a grain of sand in the vast desert of space. Even within our own solar system alone, the solar system, Earth would barely be visible. Compared to other planets within our stellar system, Earth may seem large, but in reality, our solar system is far too vast for Earth to truly stand out. So how large is our stellar system really? Now, try to imagine this. The distance between Earth and the Sun is approximately 150 million kilometers. This distance is so immense that astronomers use it as a standard unit of measurement. The distance between one object and another, specifically the distance between Earth and the Sun, is rounded and defined as 1 astronomical unit. 1 astronomical unit, or 1 AU, is equal to about 150 million kilometers, and this measurement becomes the baseline for comparing distances across the solar system. Beyond the Sun, past the planets, lies the Kuiper Belt, an icy region where Pluto resides. Pluto orbits at an average distance of about 50 astronomical units, or 7.5 billion kilometers from the Sun. That distance alone already feels unimaginably far. It makes our solar system seem vast. But here's the surprising truth. That is not the true size of our solar system. The solar system is not defined by planets. It is defined by gravity. Specifically, the farthest distance where the Sun's gravity still holds sway. And that boundary lies far beyond Pluto. At the very edge of the Sun's gravitational reach exists a distant spherical shell of icy objects known as the Oort cloud. It stretches out to nearly 100,000 astronomical units from the Sun. At that scale, astronomical units become almost meaningless. So astronomers use a different measure, the light year. 1 light year equals 9.4 trillion kilometers, and 100,000 AU is roughly 1.87 light years, nearly 18 trillion kilometers away. Any object still gravitationally bound at that distance is technically still part of our solar system. Yes, our solar system is nearly 2 light years wide. That realization alone begins to reshape how enormous our stellar neighborhood truly is. Within this immense region travels a tiny spacecraft, Voyager. Launched from Earth over 44 years ago, Voyager has been journeying outward ever since, carrying humanity's message into the darkness. Yet even after all this time, Voyager has not fully escaped the Sun's gravitational influence. It will take thousands of years before it truly leaves the solar system behind. Now, let's pull back even farther. From a greater distance, the solar system, once vast beyond imagination, shrinks into a faint, unremarkable point of light. It becomes just one star among many, drifting through a region known as the local interstellar cloud, a neighborhood of nearby star systems. Here, the sun is no longer special. Its light is indistinguishable from countless others. And then we zoom out again. Now we see the full structure of the Milky Way galaxy, a colossal system containing hundreds of billions of stars and trillions of planets spread across a disk nearly 100,000 light-years wide. From this vantage point, Earth cannot be located. The solar system is invisible. Every star is just a tiny pixel forming the spiral glow of the galaxy. But even this is not the end. The Milky Way itself is only one member of the local group, a collection of about 54 galaxies, each with unique shapes and sizes. Some are even twice as large as our own. Bound by gravity, these galaxies are slowly moving toward one another. In the distant future, the Milky Way and the Andromeda Galaxy are expected to collide, merging into a massive super-elliptical galaxy. Zoom out once more. The local group is only a small part of the Virgo supercluster, a vast region containing thousands of galaxy groups. At this scale, every dot you see represents entire galaxies. And still, we are not done. Beyond Virgo lies Laniakea, a truly colossal supercluster spanning hundreds of millions of light-years, home to an estimated 100,000 galaxies. From here, asking where Earth is no longer makes sense. Even galaxy clusters appear like drifting dust in an endless void. And finally, we reach the limit. The boundary of everything we can observe, the observable universe. This is the edge of human knowledge. Beyond it, we do not know. Some theories suggest wandering galaxies. Others propose something far more radical, that the boundary of our observable universe may be the boundary between multiple universes, a concept known as the multiverse. But for now, this remains a hypothesis. There is no direct evidence, only questions. One thing, however, is certain. The universe is expanding, and beyond our reach, it is expanding faster than the speed of light, which means the cosmos will forever hold mysteries that future generations have yet to uncover. And strangely enough, the more we learn, the smaller we feel. Not insignificant, but humbled. Because despite being microscopic in this vast cosmic ocean, humanity dares to ask what lies beyond the edge of everything. And that curiosity may be our greatest achievement. That concludes today's journey. If you found this exploration of the universe fascinating, stay with us. There are many more cosmic mysteries still waiting to be uncovered. This is the hidden cosmos, and the universe has only just begun to reveal itself.